Hi, welcome to the Shuko Math Lab differential equation problem solving section. So today we're going to work on this problem and by using the reduction method. So when how to find the second solution for the second order differential equations when one solution is given here. All right, so the problem we're going to solve here is like this. We given the one solution, y1 is equal to the x to 1/4 e to the 2 square roots of x. And this is the solution for the following. This is second order differential equation. All right, so I want to find the second solution. So, and with this given initial condition. So for these problems here, so the reduction method, I think it's a little bit like very algebra tedious. Okay, so this video may be a little bit longer than you expect because we need to go through a lot of the algebra details, and that is where a lot of people will make the mistake and get frustrated here. Okay, so just be patient and go through the algebra process step by step, and the reduction method always have its own step to follow, so it's quite mechanical, right? All right, so now let's go ahead and get started here. All right, okay. So for the reduction methods here, let's put it here. We're going to use the reduction method, and the reduction method has its own steps to follow. Okay, so here let's start. Okay, so the step number one. Okay, so I want to find my second solution. So I will say y2 and is equal to sum of the vx, sum of the function, I call it the function of the x, times your first solution. So that is always the first step to start. Okay, so now in here, so all right, so I will do here. So let's try to simplify. I don't want to have too many those subscript and make the things be complicated. So we know why that's the solution we want to find. Okay, so then the second part here. The reason why I removed the 2 because I don't want because it's already very algebra tedious. So I just want to make it a little cleaner. Okay, so the second one is here is to take the derivative with respect to the x. So this is dy dx. And then you use the product rules, right? So this is v1, v prime x, y1, and plus vx y1 prime, y1 primes. Okay, so here is the product rule. Okay, so just in case. Okay, now I'm going to do a second derivatives here, right? So like I said, the step is almost always the same when you use the reduction rule. Okay, so the second one is d squared y dx squared. So we just need to be a little bit careful because this one here is v prime x y prime. So I need to use the product rule again. So it's v double prime x y1 plus v prime x y1 prime. Okay, and then plus v prime x y1 prime plus vx y1 double prime here. Okay, so let me use a little color here. So this is the product rule for this one. So let's see my color coding. All right, so then here, this part is the product rule of this one. So here, all right. So we need to be a little careful about the algebra. Okay, so just like we say here, now let's combine the little bit here. Okay, so this one's here, I can just combine this. This is V double prime X Y1. Okay, now I have 2V prime X Y1 prime X plus 2V prime X Y1 prime, then plus Vx Y1 double prime. Okay, now let's go to the step number 4 here. Okay, so continue, use here. So we have V double prime X Y1 plus, okay, 2, nothing changed for the first couple items here. 2 prime Y1 prime. Okay, now in here, the Vx is here. Now here, what I plan to do here, okay, so I want to replace this y1 prime, okay, so to my functions here. Okay, so this will be y1, okay, so this is you take a look back here, okay, so this is my differential equations here. All right, so this is my differential equations here. So let me highlight this one. Okay, so now I'm going to, okay, so that's why I say I need to be very careful. So this is x2 prime minus x minus 3 over 16 y equal to 0. So now I am going to divide by x squared both sides here. Okay, so this one's here will be y double prime. All right, so this will be y double prime minus, and y double prime minus x squared. Then this is x minus 3 over 16 y here, right? And is equal to 0. Okay, so now in here, because the y1 is a solution, so here I just use the Vx to times these numbers here, right? So here I bring this one down, so Vx I'm going to be y prime, y1 double prime minus x minus 316 x squared y1. All right, here because this is my second order differential equation, and because y1 is the solution, so I will be able to have this. Okay, so you times this, right? So dx and this one's here is equal to, so we set d squared y1, right? So now in here, let's take a look at this one here. Okay, so here, this one is going to be equal to 0, right? Okay, so now we know for this equation here, for this one's here, okay, so this one is just my second order differential equation. See here, so what is this one? This is equal to 0. So I finally got so I have V double prime X Y1 plus 2V prime X Y1 prime is equal to 0. Wow, getting better, because right now I change this to a first order, to the v double prime x and v prime x. Now I want to change it to the first order. Then I know how to do it. All right. So after this, now my step number 5 is here. So this one's here. I'm going to change this double primes, right? So I would do a w is equal to the v1 prime x. So if I change that w, then I can change these equations. I can change the above equation will be w prime, right? Because this is v2. So I'm going to rewrite this equation by using these definitions here. All right. So let's see. So w prime. So here the y1 plus 2, because v prime is w, so it's a 2w y1 prime equal to 0. Okay, so this is equal to 0, so that's good. Okay, so the y prime, let's try to rewrite a little bit here. Y prime is dw dx y1 plus 2w y1 prime equal to 0. Now I want to single out, so I'm going to divide y1 on both sides. As you can see, the algebra really become very tedious and you need to be very careful. So this is dw dx, okay, plus 2. Now here, this is y1, this is y1 prime, and times w equal to 0 here. Okay, that's right. Okay, so now here I'm going to change this one. I want to change everything back to x. So this will be, so dw dx. I want to replace the y1 prime, the y1. So this will be plus. Okay, so this will be 1 over 2x plus 2 over square root of x, w equal to 0. Let me highlight this one because we are going to use this later. Okay, then on the side of this ones here, I want to show you how do I get this ones here, right? So basically, it's just very tedious algebra. So this is y1 prime and the y1. I just want to do that. Okay, so here, this is the 2, okay? Now, y1, like we did, the problem give us is x to the 1/4 and the e to the 2 square roots of x. Okay, now y1 prime, so we just take the derivative. So it's a power rule. So the power rule, not the power rule, the product rule, then x1/4 will be 1/4 x to the negative 3/4, right? Hold this things not change. Then plus x to the 1/4. Then take the second term derivative. Either derivative will be itself, it is 2 square roots of the x. Oh, I ran out the space. So here, then times the chain rule of the 2 square roots of x. So this will be 2 times 1/2 square roots of the x. Okay, so now you simplified it a bit. Okay, so now here, let's do this is 2, okay? So then this is x1/4 e to the 2 square roots of x, factor the e to the 2 square roots of the x out. Okay, so then the first term you have 1/4 x to the negative 3/4. Then the second term, you have x to the 1/4. Then the 2 and the 2 cancel, right? So it will be 1 over square root of x. Getting better. So now in here, we know like, hey, this one can cancel. Okay, so now I will separate this one into a 2 times 1/4 x to the negative 3/4 x to 1/4, then plus 2 times x to the 1/4 1 over square root of the x to the 1/4 here. Okay, so now these two terms become, so 2 times 1/4 is 1/2, correct, right? And then this 2 is the x to the 3/4 to the negative 3/4 or 1/4. So what is this term become? Just become an x, right? Because you move here, so it's x. Very good. Now here, the x to the 1/4 you can cancel, right? So x to the 1/4 you can cancel. So you only have the square roots down there. So you will have this is 2 to the square roots of x. All right, finally. So that's how do you get these numbers here, all right? So now we can use the next steps here. So the next step will just be we're doing the integration factor, because now I have a pure like first order differential equations, right? So step number 6, we are finding the integration. So the integration factor, right? So how do we do the integration factor? Like we did it before. So this is our px, right? This is our px. So that's why I highlighted this one, because we're going to substitute back. Okay, so the integration factor, we will say du dx is equal to this one. The px is 1 over 2x plus 2 over square root of the x times u. Correct? All right, good. So this integration factor is not too bad. So you move the u over, so you have a du over u. Then you have 1 over 2x plus 2 of the square root of x dx. Now integrate, right? Now integrate both sides. This one is not too bad. So I have ln u is equal to, okay, 1/2 ln x, all right? And then plus, so this one's here, you use the power rule, so it's 2 times negative 1/2 plus 1, then x to negative 1/2 plus 1. So it turns out this one will give you 4 square roots of the x. Okay, so then this 1/2 I can move in. I can say this is a natural log x to the 1/2 plus 4 square roots of the x. So now I can say u is equal to the natural log. So it's the so I can say u is equal to the natural log x to the 1/2 times e to the 4 square roots of the x, right? So natural log cancel. So I will say u is equal to square roots of the x times e the 4 square roots of x. Okay, so this integration factor is not too bad. Okay, now the process number 7. Remember the one I highlighted in the pink here, right? Now I need to use this integration factor times the both sides here. Okay, so now let's just be very careful here. Remember, I'm going to go to these pink ones, right? So this will be times the u, the e to the 4 square root of x, all right? Then dw dx, and then plus square root of the x e the 4x, okay, and then times 1 over 2x plus 2 square roots of the x w equal to 0. So remember that, right? So these terms, we can change that to what? To be the derivative of the product rules, right? So this one I can change it to, this is the d to the dx. You use your integration factor, square root of the x e to the 4 square roots of the x times w equal to 0. Okay, so remember we did this many times when we work on the first order differential equation. So this one's here, if you're using the product rule, so if you're using the product rule of this one, will give you this term. That's what we call the integration factor. So that's good. So here, if you want to check, you can go ahead, do the product rule for x squared, square root of x, e to 4 square roots of x. You should get this expression. All right, so now, because this is a derivative, so I integrate both sides again. So I integrate. Okay, so then this is a derivative, so this will be the square root of x e to the 4 square root of x w equal to what? Equal to some constant. All right, so equal to some constants, I call this a constants C1, first constants, right? Then now, wow, I can find my W here. So W will just be C1 times e the negative 4 square roots of the x and divided by the square roots of the x, right? You just move this term to the right-hand side. All right, now getting closer. So number 8 here. So now because I know the W is what? The W I assigned the W here is what? Is V1 primes, right? So let's highlight here. So V prime X here. Okay, so now almost there. Okay, so we say, okay, W I find out is V prime. Okay, so now I just need to find the V, then I can find my solution. Okay, so my V prime is equal to constant C1 times the square root of the x e the negative 4 square root of the x. Okay, so now in order to find the Vx, what I need to do, integrate, right? So it's a C1 and now, so here, this is e to the negative 4 square root of the x square root of the x dx here. Okay, so now in here, this one, after you integrate, this will be C1 times negative 2, and this is e to the negative 4 the square root of x plus C2. Okay, so in here, I want to use different colors here to show you how do I get this, all right? So how do I get this? This one is really pretty easy. So this is e to the negative 4 square root of x square root of the x dx. I used to u sub, right? So I used to u sub. So I will set u is equal to the square root of the x. So the du is equal to the 1/2 square root of the x dx. So 2 du is equal to 1 over square root of the x dx. So then this one's here going to be 2 and okay, so this one going to be 2 and okay, so e to the negative 4u du. So now this will be 2 times negative 4 e the negative 4u plus c. That's right. So then this one cancels, so that's why you will get a negative e to the negative 4 square root of the x plus c. That's how do I get here. Okay, so now, okay, so now we can take this out. Okay, okay, so then this one will be negative. All right, c1 times 2 and e to the negative 4 square root of the x plus c2. Okay, and so now because this is a c1, I can really change this to another constants here, right? So this is c1 times c2, right? So you just follow that. So now I can change the c1 over 2 equal to, so I will say c what? c1 star. Okay, so I can just say the c1 star e to the negative 4 square root of x. Then the whole these things I can say just another constant, c2 star. Okay, finally. So at the beginning we say, okay, this is how we define our solutions, right? Y equal to the Vx times y1. Finally, we're almost there, all right? So we finally get my solution now. Okay, so this is number 9, okay? So be careful, very careful about the algebra. So number 9, so my y2 will just be the Vx, that's right? So the Vx will be negative c1 star, right, e to the negative 4 square root of x plus c2 star. This is my Vx times y1. What is y1? Here, the problem giving you here, the y1 is x1 fourth e to the 2 square root of x. Okay, so times y1, so this is x to the 1 fourth and e to the 2 the square root of x. Okay, all right, so now let's do one more time. FOIL, so it's negative c1 star, okay, x1 fourth. So e to the negative 4 times e to the positive 2. How many we have? E to the negative 2 square root of x. Okay, now plus c2 star x1 fourth e to the 2 square root of x. Okay, now we can put it into our initial condition solving C1, C2 here. Okay, so let's try to solving C1, C2. Okay, so y2, 1. So this is y2, 1 is equal to 4. Okay, so that means you substitute x equal to 1 should be 4. Okay, so I have negative C1 star x equal to 1, so 1, so this is e to the negative 2, right? So it's e to the negative 2, okay, plus c2 star, right? Then you put the x equal to the 1 fourth, and so this is e to the positive 2, okay? So that's pretty cool. Okay, now let's take a look. Y2 prime. This is the first initial, right? So Y2 prime. Okay, so this is my Y2s, right? Okay, so now I need to do the Y2 prime. Okay, so Y2 prime. Okay, so first one's here. Let's be very careful about my product rule. So it's a negative C1 star. Okay, 1 fourth x to the negative 3/4 e to the negative 2 square roots of x, and plus, so here it's minus c1 star x to the 1/4, then e to the negative 2 square roots of the x, chain rule, negative 2 times the 1/2 the square roots of the x. Okay, now this is the first part. Okay, let me highlight here. This is the product rule for the first part. Okay, now let's do this, and then the plus C2 star 1/4 x to the negative 3/4 e to the 2 square roots of the x, plus C2 star x to the 1/4 e to the 2 square roots of the x, chain rule, so it's 2 times 1/2 square roots of the x. Oh shoot, all right, so this one, I hope did not make any silly mistake. So this is my second part, the product rule. Okay, now let's see here, okay? Let's see here, now plugged in, so the y2 prime is equal to, plugged in the c x equal to 1, right? Okay, so x equal to 1. Okay, so when x equal to 1, so this will be, so this term will be negative, so this one will be 1/4. So this is negative c1 star 1/4 e to the negative 2. All right, then this part will be x, so this one is positive is positive, so this one will be c1 star, then x, so this will be e to the negative 2. C, correct? All right, hope that's correct. Okay, so let me write here in the color code. So this is negative C1 star times 4 e to the negative 2, then plus C1 star e to the negative 2. Okay, now let's see here what we're going to have for the second part here. So this one, when x equal to, so I will have a plus C2 star, x equal to 1, I have e to the seconds, right? Now I have 1/4 here. Then plus C2 star, put 1, 1, 1, 1 in, I have e to the star. Okay, so good. All right, so now let me, so this one's here. So then what is this going to equal to? This is going to equal to 4. Okay, so now in here, so this is equal to 4, right? So now let me highlight them so we don't get confused. So this is the first equation. This is the second equation. We want to solve the system, the equations here. All right. So we're going to solve the system of the equations. All right. So C1, C1, C1 start. Okay. Okay. So now let's take a look. Okay. So we try to solve the system of the equation. Let's be very careful. Okay. Okay, so in order to simplify it a little bit, so this one's here, C1, C1. right? So it's 1/4 and negative 1/4 plus positive 1. So these two terms, I can become C1 star 3/4 times e to the negative 2, right? Then these two here, the C2 is C2 star. Then this is 1/4 plus 1 is 5/4 e to the second equal to 4. Okay, so now finally, this will be the two equation I will do. So this is negative C1 star e to the negative 2 plus C2 star e to the square equal to 4. Then this is negative C1 star 3/4 e to the negative 2 plus C2 star 5/4 to the e to the square equal to the 4. Okay, so in order to do that, just use what we learned in the algebra, right? So what I can do here in order to solve the, so I can try to do here, I can times the first equation by what? I can times the first equation by 3/4, right? So sorry, here I added one extra. That's why I need to be careful. They don't have here. Okay, so here I can times the 3/4 on both sides of the equation, then add to the second equations, right? Okay, so now that's good. So you times the here, then add to that. So this is 3/4 negative, this is 3/4 positive, right? So I can cancel that one out. So I will have a 3/4 E2 C2 star add C2 star 5/4, right? 5/4 E2 is equal to 3 plus 4, right? Because you times 3/4 adding. Okay, so now I can set a C2 star E the second 3/4, 5/4. Oh, pretty good. It's A/4. A/4 is 2, right? So this is 2. So this is A/4. It's 2 and is equal to 7. So this one is 2. So what is my C2 star? So my C2 star will be 7 divided by 2, the e the square, right? So that's why I will have 7/2 e to the negative 2. Wow, that is a long way to get it. Almost there. So this is my first C2. All right. Then you can use your algebra. Okay, so you will just use the substitution, right? So you substitute the C2. Okay, you can substitute the C2 to here and try to solving for the C1. Okay, so solve for C1. Okay, solve for C1 star by substitutions, right? So you already got the C2 is 7/2 e to the negative 2. So your C1 going to be, let's see here. So negative C1 star e to the negative 2 plus 7/2 e to the negative 2 times e2 equal to 4. So negative C1 star e to the negative 2 plus 7/2 equal to 4, right? All right, so the 7/2 equal to 4. All right, so let me see here, make sure I did not do anything stupid. Okay. All right, so here I will have negative C1 star e the negative 2. So 4 minus 7/2. So it's giving you 1/2. right? So that's why C1 star is going to be negative 1/2 to the e the square. Gee, all right, we finally got this one. So let me highlight it so we know how to find it. So this is C1 star. Okay, so finally, okay, so where is my y2? Let's go back all the way to here, right? So this is my y2, right? So finally I find the C1 and the C2. Okay, so now let's try to put my C1, C2 back to this equations here. So my final solutions, all right? My final solution, y2, will be, okay, C1. So here, look here, let's see, negative C1. Okay, negative C1. So positive, negative, negative, positive. So negative C1 is 1/2 e to the second times, right, x, okay, what do we have here? X 1/2, 1/4, e the negative 2x. So I have x 1/4 e to the negative 2 square roots of the x plus, okay, C2 here, all right, so it's 7/2 plus 7/2 e to the negative 2 x to the 1/2, right? And then e to the positive 2 of the square roots of x. All right, so if you want, you can simplify this a little bit. If you can take the 1/2 out, x to the 1/4 out, then here you will have e to the square times e to the negative 2 square roots of the x, right? And then plus 7, then e to the negative 2, to the 2 of the square roots of x. Oh boy, right, finally we got it, okay? So like I mentioned, for those type of problem, the deduction type of the problem, frequently you will bump into the problem require a lot of, the algebra. Just be patient and be very careful to stop and double check your algebra. You will be good, all right? I'm glad I'll be able to help you out with this problem. Okay, so though I think we're all tired with such a long problem. I guess I will talk to you in the next time. Okay, bye. You have a good day. All right, bye-bye.